Like you did protein folding in your chemistry, in your PhD. So it's like I remember you did chemistry PhD at the University of Chicago, and also you're very educated in physics and math.
Yep.
So how do you connect the dots and then apply them in your current research?
So you're learning all your life, and I am a firm believer that your academic journey has to continue both through formal training, but also training in the laboratory, training through colleagues and collaborators. So certainly you have to take certain classes and you have to do certain things. But my academic journey, I would say, is continuing very much so. So what I have, I think, taken from that experience is being comfortable with quantitative reasoning and quantitative thinking, even though I'm not doing any protein folding, but I'm very comfortable with computational modeling that I sort of learned in that area. I'm very comfortable with sort of, I would say, basic theoretical approaches to address the problem. But I'm also very excited about the role of basic science. So the thing that I actually took is not just sort of set of tools, but also this recognition, this excitement about the necessity of fundamental curiosity-driven science, and how that plays a role. I mean, we see the current progress in COVID vaccines with mRNA, but it didn't sort of just start in 2020. It stood on sort of the shoulders of basic science for decades when people had been looking at mRNA. People had been thinking about mRNA vaccines in the 1980s. Even well before it was cool or the exciting thing to do. And that sense of the importance of basic science is critical. So that's one thing. The second thing, and sort of the computational approaches, the second thing that I think I find important is being able to appreciate the interdisciplinary nature of research, which is my own personal experience. As you noted, that I was trained in mathematics and physics and chemistry and physical chemistry, and my PhD was almost all theoretical. It was very computational. It was very heavy on physics side of things. And over time it changed, but it still gives me, I think, an appreciation for using tools of analysis and theory, whether that theory is in physics or in chemistry or elsewhere, and really creating theoretical frameworks that allow us to analyze things, even complex questions. Proteins may seem something that is very simple, very small compared to the kinds of questions that we look at now, but I think the training in complex systems, in being able to understand things that have many moving parts and trying to make some kind of sense out of that, is something that I still find very exciting.
Cool.